project under Dr. Park's data mining class, where I have tried to implement 6 different image classification techniques on the mango leaf disease dataset from Kaggle. In the beginning, I have like tried to basically do some training data split using scikit-learn, where I'm trying to create several folders for validation training and the test sets, and also perform some exploratory data analysis on the data in order to understand the data better and clean the data. As the images, for example, were of different sizes, I've tried to reshape the images and I've performed some label encoding on the data and also tried to execute opening the images and seeing various types of classes on the data set. I have uh, started by implementing the convolutional neural network algorithm, wherein I have initially first normalized the data, encoded the data, encoding the data labels, and then implemented the model by performing various hyperparameter tuning. After first creating a CNN model with 5 different layers. Uh, Here I have briefly explained all the hyperparameter tuning that I have done. Um, 16 different techniques were utilized, where I have changed the size of the epochs on which I was running the models, like changed the uh, type of learning rate, and increased and decreased the number of layers uh, in the various CNN models. I have performed it for 3 different models and recorded their accuracies and printed their classification reports. Next, I have tried to also report their accuracy and loss graphs in order to understand how the validation accuracies were against the training accuracies for all the 3 models as seen here. And then I have tried to predict the mango leaf diseases on and try to predict the output based on my models on the validation and test sets. And I mean, you can see here that this particular image was originally Anthraconos, and after training it through the model and like the model predicted that this image was powdery mildew, having powdery mildew disease. Uh, and Similarly, I have implemented the image classification techniques for various other models, starting with support vector machine, where I have briefly explained the model and mentioned its advantages and disadvantages, and like coded and trained the model and fitted the model and then predicted the model for the training and validation accuracies and printed their classification reports. I performed the same activity for random forest classifiers and logistic regression model and K-neighbors classifier algorithm, and lastly, Naive-Bayes classifier algorithm, which we learned about in our assignment 2. Um, in the end, I have compared all the model accuracies using a graph, wherein the final inference was that the convolutional neural network model, the first one, had the highest accuracy of 84.48 percent, and this particular model trained even better and predicted better than the random forest model, which was second highest, which was with the second highest accuracy. The least accuracy was seen in the uh, in the second CNN model, which I had ran on 20 epochs, and probably because of overfitting of data. And I have listed the various technical challenges that I have come across during this implementation, and all the various links have been shared here. And